FastMCP 3 employs a declarative UI composition patterned through its Prefab app integration, where component hierarchies are constructed via context managers to render dynamic system status dashboards. The framework's tool decorator mechanism exposes Python functions as MCP endpoints, enabling seamless conversion of service health data into interactive visual representations. We're about to examine how the system status tool initializes a service monitoring interface, using layout components like column, row, and grid to organize service cards, while conditional badges and progress indicators provide immediate visual feedback about system health. The implementation demonstrates how static service data gets transformed into a responsive dashboard through Prefab's component-based rendering pipeline. From Prefab UI, components import. Column, row, grid, heading, text, muted, badge. Card content, progress, separator. From Prefab UI, app import Prefab app. From FastMCP, import FastMCP. MCP equals FastMCP monitoring. At MCP, tool app equals true. Def system status, Prefab app. Is show current system health. Services equals. Name, API gateway, status. Healthy, OK, true, latency MS, 12, uptime PCT, 99.9. Name, database, status. Healthy, OK, true, latency MS, 3, uptime PCT, 99.99. Name, cache, status. Degraded, OK, false, latency MS, 45, uptime PCT, 98.2. Name, queue, status. Healthy, OK, true, latency MS, 8, uptime PCT, 99.8. All OK equals all's OK, for S in services. With column gap equals 4, CSS class equals P6 as view. With row gap equals 2, align equals center. Heading, system status. Bad. All healthy, if all OK else degraded. Variant equals success, if all OK else destructive. Separator. With grid columns equals 2, gap equals 4. For SVC and services. With card content. With row gap equals 2, align equals center. Text name, CSS class equals font medium. Bad. SVC status. Variant equals success if SVC OK, else destructive. Muted for response, SVC latency MSMS. Progress value equals SVC, uptime PCT. Return Prefab app view equals view. This implementation demonstrates a status dashboard pattern using Prefab UI components to visualize system health metrics. The code creates a grid of service cards, each displaying key indicators like latency, uptime percentage, and operational status through badges and progress bars. The design uses a 2-column layout with responsive cards that combine text labels, visual indicators, and progress meters for at-a-glance monitoring. The pattern leverages Prefab's component system to build a hierarchical view. A top-level status badge shows overall system health, while individual service cards provide detailed metrics. The all-OK calculation aggregates service statuses to determine the overall system state, which drives the variant styling of the summary badge. Each service card uses conditional styling on its badge component, switching between success and destructive variants based on the service's OK flag. This approach provides immediate visual feedback about system health while maintaining a clean, scannable interface. The use of standard UI components ensures consistency and accessibility, while the grid layout efficiently utilizes screen space. The pattern is particularly effective for operations dashboards where quick status assessment is critical, though it assumes the data structure remains consistent across services. Let's break it down. From Prefab UI, components import. Column, row, grid, heading, text, muted, badge. Imports UI layout components from the Prefab UI library, specifically column, row, grid for structural layout, heading and text for typography, muted for secondary text styling, and badge for status indicators.
Card content, progress, separator.
Imports UI components from a component library, card for container styling, card content for inner content areas, progress for progress indicators, and separator for visual dividers between elements. These are likely being used to construct a user interface with structured content sections and progress tracking.
From Prefab UI, app import Prefab app.
Imports the Prefab app class from the Prefab UI app module, providing a base application class for building prefabricated UI components in the FastMCP 3 framework. This class serves as the foundation for creating structured UI applications with predefined components and layouts.
From FastMCP, import FastMCP.
Imports the FastMCP class from the FastMCP module, which provides the core functionality for implementing Model Context Protocol (MCP) servers. The imported class will be used to create MCP server instances with configurable identifiers.
MCP equals FastMCP monitoring.
Creates an instance of FastMCP with the server identifier monitoring. The string parameter serves as a label for the server that will appear in MCP protocol handshakes, allowing clients to identify this specific server instance. This line initializes the FastMCP object, but doesn't configure any operational behavior. The identifier is purely for identification purposes in the protocol.
At MCP, toolapp equals true. Def system status, prefab app. Is show current system health.
Defines a FastMCP tool function named system status that returns a prefab app instance. The @MCP toolapp equals true decorator registers this function as an MCP tool with the app flag set to true, indicating it's an application level tool. The docstring, show current system health, serves as the tool's description in the MCP protocol. When called, this function will execute and return a prefab app object, though the specific implementation details of what that app contains aren't visible in this segment.
Services equals.
Initializes an empty list named services to store service configurations or instances.
Name, API gateway status. Healthy, OK, true, latency MS, 12, uptime PCT, 99.9.
Defines a dictionary entry representing an API gateway service status with 5 key value pairs. Identifies the service as API gateway, reports its status as healthy, confirms operational status with OK, set to true, records a 12 ms latency measurement, and shows 99.9% uptime.
Name, database status. Healthy, OK, true, latency MS, 3, uptime PCT, 99.99.
Defines a dictionary entry representing a database status report with 5 key value pairs. Identifies the component as database, indicates its operational status as healthy, confirms it's functioning properly with OK, set to true, reports a response time of 3 milliseconds via latency MS, and shows 99.99% availability through uptime PCT.
Name, cache status. Degraded, OK, false, latency MS, 45, uptime PCT, 98.2.
Defines a dictionary entry representing a degraded cache system with status indicators and performance metrics. The cache is identified as cache with a degraded status, marked as not OK, showing 45 ms latency and 98.2% uptime.
Name, Q status. Healthy, OK, true, latency MS. 8, uptime PCT, 99.8.
Defines a dictionary entry representing a Q status with key metrics. Identifies the component as Q, reports it as healthy with operational status, OK, set to true, shows current latency of 8 milliseconds, and indicates 99.8% uptime. This appears to be a health monitoring data structure tracking system performance metrics.
All OK equals all's OK for S in services.
Checks if all services in the services collection have their OK status set to true by iterating through each service dictionary and evaluating the Boolean value of the OK key. The result is stored in the Boolean variable allOK, which will be true only if every service has OK, true, otherwise false.
With column gap equals 4, CSS class equals P6 as view.
Creates a column layout context with a 4-unit gap and applies the CSS class P6 for padding, assigning it to the variable view. This establishes a container with specific spacing and styling that will contain subsequent UI elements.
With row gap equals 2, align equals center.
Creates a row layout container with 2-unit gap spacing between elements and center alignment for all child components. The with statement establishes this as the current layout context for any UI elements defined within its indentation block.
Heading system status.
Creates a heading labeled system status using the heading component. This is a UI element that displays a section title in the interface.
Bad. All healthy if all OK else degraded. Variant equals success if all OK else destructive.
Creates a badge component with conditional text and styling based on the allOK Boolean. When allOK is true, displays all healthy with a success variant style. Otherwise, shows degraded with a destructive variant style. The component visually represents system status through text and color coding.
With grid columns equals 2, gap equals 4.
Creates a grid layout context with 2 columns and a 4-unit gap between them. This establishes a container where subsequent UI elements will be arranged in a 2-column format with consistent spacing.
For SVC and services.
Iterates through each service in the services collection, assigning the current service to the variable SVC in each iteration. This is the header of a for loop that will execute the indented block below for every service in the sequence.
With card.
Creates a context manager using the card class, which typically initializes a UI card component in FastMCP 3. The with statement ensures proper setup and teardown of the card context, though the specific card content or configuration isn't visible in this segment. This is a common pattern for defining scoped UI components in the framework.
With card content.
Creates a context manager for card content, which will manage the lifecycle of a card content section in the UI. The with statement ensures proper setup and teardown of the card content context, though the specific content isn't visible in this single line.
Text name. CSS class equals font medium.
Renders the value of SVC name as text with the CSS class font medium applied, which typically makes the text appear with medium font weight in the user interface. The text component is being used to display this service name with specific styling.
Bad.
Creates a badge instance with no visible parameters or configuration. The line shows the instantiation of a badge object, but doesn't demonstrate any specific functionality or properties being set.
SVC status
accesses the value associated with the status key from the dictionary named SVC. This retrieves whatever status information is stored in that dictionary entry, which could be a string, Boolean, or other value indicating the current state of the service represented by SVC.
Variant equals success if SVC OK, else destructive.
Assigns the string success to the variable variant if the value of SVC OK is truthy, otherwise assigns the string destructive. This is a conditional expression that evaluates SVC OK and selects one of two string literals based on the Boolean result.
Muted for response, SVC latency MSMS.
Logs a muted message containing the service response latency in milliseconds, where SVC latency MS provides the numeric value. The output follows the format response, XMS, with X being the actual latency measurement.
Progress value equals SVC, uptime PCT.
Creates a progress component with its value set to the uptime percentage from the service dictionary. The component will visually represent this uptime value, likely as a progress bar or similar indicator in the UI.
Return prefab app view equals view.
Returns a new prefab app instance initialized with the provided view parameter. This creates a configured application object that incorporates the specified view component, ready for further processing or execution in the FastMCP 3 framework. The view parameter determines the visual or structural component that the application will use. This implementation showcases FastMCP 3's declarative UI composition through Prefab app, where the system status dashboard is built using nested context managers for layout components. The @MCP tool decorator exposes the function as an MCP endpoint, while the hierarchical structure of column, row, and grid components organizes the service cards into a responsive two-column layout. The design leverages conditional rendering through the all-OK aggregation and individual service status checks, driving the variant styling of badge components between success and destructive states. This creates immediate visual feedback about system health at both the overall and individual service levels. The pattern effectively transforms static service data into an interactive dashboard, demonstrating how Prefab's component-based pipeline enables clean separation between data structure and visual representation while maintaining consistency through standard UI components.
The namespace whispers its name to the context, but the context only hears echoes of itself.